Welcome to my channel SK Vidyan Physics classes. I shall discuss an important problem for NEET as well as JEE. The problem is a positive charged particle Q of mass m passes through a potential difference V. This particle moving along x-axis enters a region where an electric field E exists along the positive y-axis. The electric field exists in the region bounded by lines x equal to 0 and x equal to a. Beyond the line x equal to a, there exists a imaginary field of strength B directed along positive y-axis. Find at which point does the particle meet the line x equal to a. Second, pitch of the helix formed after the particle enters region x greater than equal to a. Now, the problem is like this. A charged particle plus q of mass m passing through a potential difference of v gains a velocity u0 and enters into region x equal to greater than 0, where there is electric field directed along positive y direction. Now, first we shall calculate what is the velocity u0. Now the charged particle passes through a potential difference of V. So the energy gained by the charged particle is charge into potential difference. It is equal to gain in kinetic energy half m u0 square, or u0 is 2qv by m root under. This is the velocity gained by the charged particle after passing through a potential difference v. Now this charged particle enters into an electric field directed along y direction. Now the force exerted on the charged particle due to the electric field is also directed upward. Direction of the force acting on the positive charge is same as direction of electrical intensity. Now the charge, it has initial vertical motion 0 and gains velocity along y direction and strikes the line x equal to a, say at point P. We have to find out at which point does the particle meet the line x equal to a. Now the coordinate of the point P is to be determined. Now how to find out? See, the motion along x direction remains constant, uniform, because the force is exerted on the particle along positive y-axis, whereas the acceleration of the charged particle is along positive y-axis and the motion along x-axis is uniform. So the time the charged particle takes to reach the point P is equal to distance a by speed. Now during this time, the distance in vertical direction covered by the particle is, say, y equal to initial vertical motion 0. We shall use the formula s equal to ut half at square. Y, initial vertical motion is 0, half. Acceleration of the charged particle is q, e capital E is the force per unit mass is acceleration, half a t square, and t square is equal to a square upon u0 square, and this is equal to half q e force by mass a square, u0 square here is 2 q v in the numerator m got cancelled, q got cancelled, So Y equal to E, intensity of electric field is 2 into 2, 4 V A square. Displacement of the particle is Y equal to intensity of electric field, A square. A is the distance, 4 V is the potential difference. So the coordinate of the particle, the coordinate of the point P is, x coordinate is A and y coordinate is intensity E, 4 V the potential difference, A square. This is the coordinate of the particle, coordinate of the point P. Now this particle moving in the electric field describes a parabolic path. We can also find out the locus of equation of locus for the particle. Even though it is not asked, you can find out by eliminating time t, obtaining relation between x and y. Now, but when the particle P reaches the point, when the particle reaches the point P, it has a velocity, say y component of motion, and this is the x component of motion, which is same as u0. And velocity along y direction is equal to v vertical, final vertical motion, initial vertical motion is 0 here, v equal to u plus at. Acceleration is equal to charge of the particle q into E force by mass. V equal to u plus at, this is a time t equal to a by u0. This is the y component of motion at this point P. So there may be confusion. I am writing this Vy, that is the y component of velocity. As a result, we can say that the velocity at point P can be, say in general, so let it be u equal to x component of motion, that is u0 I cap, and by, that is q e phi m a into u0 j cap. As a result, the force when the particle enters into the magnetic field, the magnetic field exerts a force on the charged particle, and the force is given by F equal to Q V cross B. Instead of V, I write x component of motion u0 I cap, y component of motion q e m a u0 j cap cross b j cap. Since the magnetic field of induction B is directed along y-axis, positive y-axis, it is b j cap. When you take the cross product, this force acting on the charged particle is q u0 I cap cross j cap, and this term becomes 0. That is j cap cross j cap 0. This shows that the magnetic field exerts no force on y component of motion. Y component of motion remains uniform, as well as the x component of motion remains uniform. That is, the magnetic field force, the force due to magnetic field does not affect the motion of the charged particle, that it does not increase the kinetic energy of the charged particle, it does no work on the charged particle. So what happens then? So only the force is q u0 into B, Q U0 into B, I cross I cap plus J cap is K cap. That is, the force is along Z direction. And what happens then? The charged particle, while entering into the magnetic field, which has a motion along Y direction and motion along X direction, experiences a force along Z direction, and this force drags the particle to follow, makes the particle to follow a circular path in a clockwise fashion in the plane containing force and u0 velocity. That is, the motion takes place along, the motion is circular along circular path in xz plane. But because of the y component motion, while the charged particle describes a circular path, it simultaneously follows, it moves off along the positive y direction. It is dragged along positive y direction. And while revolving in a circular path, it describes a helical path. It moves off because of the y component motion. So how to find out the pitch? How to find out the radius? Now, this force is, or it provides the necessary centripetal acceleration for the charged particle to follow a circular path. Now, the force Q U0B equal to M U0 square upon R. R is the radius. Now, this is Q B equal to M U0 upon R. This is M omega, or M omega, or omega, this is 2 pi by T equal to Q B by M. M omega, that is M 2 pi by T, 2 pi by T equal to Q B by M. This shows that the time period does not depend upon the radius. Time period of motion of the particle in a circular path depends upon the charge, mass of the charge, and magnetic field. And 2 pi f equal to Qb by m, and f is known as cyclotron frequency that we can find out. It is very important for examination point of view. Now what happens? This time period T is equal to 2 pi m by qb. Time period T equal to 2 pi m by qb. Now once you know the time period, we can find out the pitch. So how to find out the pitch? Now pitch is the distance covered by the charged particle along y direction in a time, that is in the time the charged particle describes one revolution. That is, vertical component of motion is uniform. So vertical component of motion, that is vertical velocity, multiplied by the time period gives you the pitch. So pitch is equal to, say L is the pitch, it is equal to time period into vertical component of motion, say Vy or Uy, whatever it is called. Now what is vertical motion? Vertical component of motion is Q E A by M U 0. This is the vertical component motion that the charge particle has gained while moving from x0 to x equal to a. Now, so the pitch equal to q e a by m u0 into time period 2 pi m by q b. So q gets cancelled, m gets cancelled, and pitch equal to 2 pi e a 2 pi e a b u0. So what is the conclusion? The conclusion is the charged particle while entering into the magnetic field follows a helical path, and the pitch of the charged particle depends upon intensity of electric field, and a the value x0 to x equal to a, and induction, that is a magnetic induction, and x component of motion which the particle gains after passing through potential difference. And here, even though it is not mentioned, there is a condition that the charged particle never attains very high speed, that is, the motion is non-relativistic. Otherwise, we cannot solve this problem in this manner. The mass will vary, relativistic mass is different. So we have found out that the point where the particle strikes, and we have found out the path of the particle. Sometimes in the examination, it is asked to find out the equation of the trajectory of the particle in electric field. In that case, we can say, here we can explain that let the electric field be along y direction. This is the x-axis, and choose any point P having coordinate x, y, and the particle enters into the electric field with a velocity u0, say. Now what happens? This point, this distance is x, this distance is y, and y equal to half, because initial vertical motion 0, y equal half a t square, and half a is acceleration, that is charged particles, say q, intensity electric field E, force by mass is acceleration, and t square is the distance, the time taken to reach the point P, is equal to x, distance x by u0. u0 motion is uniform, that is motion along x-axis is uniform because there is a force acting on the charged particle in vertical direction, say y direction. So this is the uniform motion, and this is equal to t square, x square, u0 square. So y equal to qe by 2m x square u0 square, and x square equal to 2m u0 square by qe into y. So x square equal to 2m, x square equal to 2m u0 square by qe into y. This is the equation for a parabola. Here, to eliminate time, if you eliminate time from these equations, we get relation between x and y, that is the equation of trajectory. This is also asked in the examination. I hope all these discussions will be helpful for the students appearing NEET and JEE. Thank you.